right, so let's look at some more problems from these first degree equations, and I like to be completely transparent. I think these three are a little bit more challenging. In all honesty, they're probably the most challenging for our exam 1 material. So just so everybody knows, that doesn't mean we need to give up and not try, but you also shouldn't feel bad if you need to watch the video a couple of times. Also, along those lines, I'm going to work these problems all one way. And in MyMathLab, if you go to view an example, some of the examples will work the way I did, and some of the examples will show you a different way to work them. And that different way is perfectly fine. I think it's great that we might have 2 methods to work a problem, that we have a little bit of choice, and you can do what works best for you. So I'm kind of purposely going to deviate a little bit from MyMathLab here, but I think you should feel like you can choose either way, and I'm happy to grade either way. Or if you had another professor before or something that might have done these a different way, it is completely fine. All right, so this first one, we're investing $20,000 at 5%. So these percents, I'm going to change to decimals. And from us all of these, we're going to see that we're going to be multiplying our money times something. So we're going to, in this case, we're going to be multiplying the money times that percent. So $20,000 times 0.05. We want to know how much. That means we don't know what it is, so it's going to be a variable. So I'm going to call it X. You can choose whatever variable you want. So how much money is going to go with the 4%? So I'm going to put an X because I don't know how much times the 4%. And then my right-hand side over here is going to be my total. Total, I should get 4.8%, so that's going to be my percent. I'm going to put it over here for just a second. Watch out, when you move that decimal place, you can divide by 100 or move 2 decimal places. Sometimes that extra decimal place gets people. Now the tricky thing is what I'm going to put with that. The total is both the $20,000, hopefully I gave myself enough space, and the X. That came from the 20,000 and the X. I combined those together. So this is the equation that I have to solve. Solving it honestly is not the hard part. We just practice that on the other 3 examples. It's the setting up that's a little bit challenging. All right, 20,000 times 0.05 is 1,000. This is going to be 0.04x is equal to, and I have to distribute. I know it looks backwards, but I'm going to still distribute that. 20,000 times 0.048 is 960, and then 0.048x. Now I need to get the x's together, and I need to get the plain numbers together. Your choice on what you want to move over. I'm going to move the 960 first. You could have moved the x's. You could have moved the 1,000. All those choices are going to work out fine in the end. That's going to leave me with 40. Haven't done anything to the 0.4x or the 0.048x. Trying to get all the x's together. Don't move this 0.048. It's by itself. So if you go to move that, you're going to give yourself a world of hurt, to be honest, because you're going to end up with nothing over there. Instead, move the x, the other x, to be with it. So I'm going to get 40 is equal to 0.008x. Last step, divide by 0.008. So my final answer is x equals $5,000. So that was what I was trying to solve and got my final answer there. All right, let's look at another one of these. All right, so this is the one that MyMathLab might work slightly differently, and it's going to be okay. You can work it my way or their way, or maybe if you had another professor sometime that taught this topic. Both ways are taught pretty equally, so one way is not better. I'm not doing something crazy weird, just kind of like 50% of the time, so who knows what you might have seen before. So for this one, I'm kind of going to start with 2 equations. My first equation is all going to deal with the money here. So I'm at a rock concert, and there are 2 types of tickets. So I'm going to have 2 variables for a second. I'm going to have a variable with the $35 and a variable with the $55. And that's going to be equal to the total amount of money. Notice all of those had money as their units. Now I have not used the 9,500, so I'm going to make another equation that uses the 9,500. That's just my tickets. There's no money with that, so I can just ignore the money part above because X and Y actually stand for my tickets. X are the cheaper tickets and Y are the more expensive tickets. So they're just plain tickets, and the unit for that I put up here was tickets, so that's why I can do that. Now I've got these two equations. I'm going to take the simpler equation, so the one I have down here in blue, and I'm going to try to get one variable by itself. I'm going to solve for a variable. It doesn't matter which one. I'm just going to rewrite it over here. So let's say I move Y over. Now I've got X equals 9,500 minus Y. What I'm going to do here is what's called substitution. I'm going to take this X and I'm going to plug it in to that other red equation. And I can do this. It's completely fair and legitimate to do. And I have a little kind of analogy to help you figure out what's going on. So everybody, you know, kind of goes by your first name or maybe a nickname with your friends, right? You might just be called, like my son's name's LaRue. So, you know, his friends just call him LaRue, some call him Rue, that sort of thing. Well, I usually call him LaRue too. But when he's in trouble at home, I say his entire name, LaRue Nahom Hedges, and he knows he's in trouble. He's the same person whether it's his friend calling him Rue or his long name when he knows he's in trouble. Same thing here. X is just his short name, Rue. His whole name over here, it's nasty and he knows he's in trouble, but it's still his name. So instead of saying 35X, I'm going to say 35 times the entire nasty name. Now I have an equation that looks like that one from example 4 up above. It's got one variable I can distribute and solve. So I want you to pause and see if you can just try to get Y by itself. You're going to have Y equals an answer. So go ahead and hit pause and see if you can do the algebra to solve this equation. All right, coming back from that pausing and working, and it is really important that you try these problems on your own. That way you can kind of see what mistakes you might make before you get into the homework, because you want to make the mistakes now instead of in the homework. I distributed that first parentheses. I kept the 55. I've got some like terms here. Like terms mean I do exactly what they say. I don't need to do the opposite or anything like that. Negative 35 plus 55 is 20Y. Trying to get that 20 by itself. So I'm going to move over the other numbers. So I'm going to get 20Y. Ooh, I don't think I'm giving myself enough room over there. Right over here. 20Y is going to be equal to 99660. I'm going to divide both sides by 20. So Y is equal to 4983. So why are the $55 tickets? So these were the $55 tickets. The directions ask me each type, so I'm also going to find the X. I'll do it down here and then I'll erase it. The X tickets, if we remember, we're going to take 9,500 minus our Y. So 4,517 of the $35 tickets. Whew, that was a doozy of one, but we're going to practice another one right down here below.